I think that's pretty good, honestly.
Ladies and gentlemen, welcome to the stream. We're playing video games. I'm gonna plug my headphones into the laptop and make sure that everything is leveled nicely. But oh, I can hear my laptop. That's not good. Oh, that's the wrong button. Function, shut up. That's the function shut up button. I'll be right back. I'm gonna plug my headphones into the laptop. All right.
It always works perfectly. It always works perfectly until stream starts.
Yeah, I guess it's pretty good. We're gonna put on Minecraft in the background as always.
Oh, perfect.
So there you go. That is a compact little T flip-flop for you.
I need my
Thanks for watching,
Azuma
and I'll catch you next
ASMR.
time.
Yeah, there you go. That is a compact little T flip-flop for you. Okay, that's good. Okay, let me plug back in. All right, Japes, I'm back with you.
Yay!
So, what you're seeing on the screen is the culmination of all of our hard work. And we're not even remotely close to being done, because it's actually kind of garbage right now. But there is one really cool thing I'll show off. So this is something that C# does, which is if you run a function over and over and over again, eventually the real-time compiler goes, that seems important. I'm going to allocate more memory for that. Or not memory, but like more resources, you know? So it starts to speed up that function. It makes the function more efficient. It allocates more resources to make the function more efficient. And then the function gets more efficient. Now watch this. This is insanely cool. So look how slowly it moves for like a second, and then it speeds up. Look at that. It speeds up.
Interesting.
And then like I can even restart the room, and it knows to keep using that function. Sorry if you have epilepsy. I don't know why dragging the window around causes it to think that it doesn't need the function anymore. But that's a thing. So this is 50 objects. They're each checking every other object for collisions. So that's 49 squared collisions. It's about 2,400 collisions total. I was testing this on my laptop earlier with 100 objects. I'm going to do that here as well. This is scene VHS. Originally, I was going to have them bouncing off the walls, but immediately before even attempting to do that, I decided that proper bouncing is too annoying and I wasn't going to deal with it. So they wrap around the screen instead. Anyway, if I set this to 100, there will be 100 of them. Fancy that. If I set it to 101, then they'll each be doing 100 collisions, and it'll be 10,000 collisions total, which is a nice, even, round number. We like our round numbers.
10,000 collisions.
10,000 collisions.
That should have been the title of the stream.
You're actually right. 10,000
I made
collisions will give you
10,000
such a kick in the
collisions.
nut. I can change it. I can still change it, right? Let's go to YouTube Studio. This is not getting faster. Wow.
Maybe
Okay.
we don't change the title then.
I'm just doing 100. I can still change it to 10,000 collisions. I'm gonna leave it as PyCharm hates him.
PyCharm hates him.
No, I'm gonna leave it as Visual Studio hates him.
Oh yeah, that.
So, the funny is that my laptop is better than my desktop now, because my laptop can handle this no problem. Let me change the screen. You guys can watch. Let me change the stream name. In the meantime, you guys can watch the slideshow.
I do like me a good 0.5 FPS game.
Game Engine Dev. Looking Eyes. Yes, this is Game Engine Dev. Hello, Real. If you guys are longtime viewers, Real is the server owner from when we did Minecraft.
Oh hi, Rail. I don't know if you remember me. I'm Japes.
Actually, I guess technically I was the server owner, but he was like in charge of it.
Right.
How in the world do I change the name of this stream, actually? Wait a minute. I think I can just go here. View channel. I'm gonna go to my streams. Yeah, this one. Edit video. And then 10,000 collisions. what is it? I'm gonna say this game requires 10,000 collisions. Game engine development. Visual.
It has to be
Studio
all
8
caps
said.
too. Well, it has to be all caps, like it's a Mr. Beast video or something.
It is all caps. No worries. I hit the. I was exactly 2 characters over the limit, and I'm like, oh my gosh, where am I going to delete 2 characters? And then I remembered that I have a million exclamation points at the end.
That's where you delete 2 characters.
That's where I'm deleting 2 characters. But that's my decision. Okay. The stream title has changed. I'm going to refresh and see what happens. This game requires 10,000 collisions. Game engine development. Visual Studio hates him. Real says hello, Japes.
I saw that, yeah.
Okay,
I saw-
yeah.
No, son.
I was just gonna say that 10,000 collisions is actually too much for my sad little tower, but maybe at the end of this it won't be too much and we'll have seen improvement.
Yeah.
Like,
How is
sad
your
little
laptop
tower.
better than your tower?
It's just a new generation. Tower's running, well, it shouldn't be like graphics card related, but like I got my tower when the 4000 series was out. My laptop is a 5000 series.
Mm.
And my laptop just simply has a newer processor.
That would probably do it.
So it can't handle 70 either. I'm actually kind of insanely impressed because 10 fewer objects here means 100 fewer collisions. So my laptop is crushing it apparently because this is still slow on the tower. Okay, there we go. Yeah, that's what I wanted to show. So check it out. Like, if we don't run the collision code for a second and then we let it go, it's super, super slow, and then it just gets faster.
And that's something that Visual Studio just does? Or your
No,
computer
that's
does?
that's C#. C# uses a just-in-time compiler where it compiles methods as you need them.
Huh. So that'll be true for anyone's computer running a game then, huh?
Correct.
Nice.
But this is honestly slower. This, I mean, I can think of lots of reasons why, but there should be no reason why. Again, I can think of lots of reasons. I'm lying to you. There should be no reason that we can't run 10,000 pixel perfect collision checks and still have it running smoothly at 60 frames per second. Like, there's absolutely no reason. I'm lying. There's a lot of reasons, but there's absolutely no reason. So that's when I went back over to game objects. Okay, so what we're doing, first thing I'm going to do is kind of, I guess I'll walk you guys through how we got here from last week, 3 weeks ago. And this stream is pretty much going to be dedicated to following that route of the current algorithm and cleaning up things that we don't need anymore, because I completely changed the algorithm and ripped out a ton of code. And there is now tons of code I just don't need anymore. There's a lot of code I don't need anymore.
You did that like twice, didn't you?
Don't talk to me. Yes, I've had to do that a few times, and it's actually been a little miserable. So let's pull out Paint. Everybody's favorite. And what's really cool about this new algorithm is much easier to explain. The other algorithm was a little bit iffy, because I was saying, like... Come on. I was saying you'd have a oh, my bad. I was saying you would have a rectangle like this. Pretend I didn't completely mess that up. So you got a rectangle like that. And then maybe you've got another rectangle like this, right? And so, and of course these rectangles are actually sprites. So they might be like the weird pawn that I'm using for my stuff. I'm using to demo my collision engine. And so if it looked like, that is just genuinely abysmal, but you guys are going to have to put up with it. Actually, I should have just done that in a different color. I'm going to do this in red. I'm going to do this in orange. So I've got a guy. And right away you can see I've made them overlap. So these are two sprites, and they have these rectangular bounding boxes, so that's important. And previously what I showed you is I would take one of these guys, turn them right, like right side up, so they're just straight up and down, put them in like the top left corner, and as I'm doing that, I would also move the other guy you know, like just like when you're doing algebra, you know, what you do to one side of the equation, you have to do to the other. Whatever I do to the one guy, I have to do to the other guy. So if I'm taking this man and I'm rotating him slightly and then moving him all the way here, I have to rotate this guy by the exact same amount, and I have to move him by the exact same relative amount. And by doing that, the overlap here stays the same. Right?
Yeah, makes sense.
Okay. And then on top of that, so now that this guy is fully upright, I have a rectangle of potential collisions that I can check. So I'm like checking every single pixel in this rectangle. And I want to see if any of those pixels line up with the pixels in the other object. Specifically the opaque pixels. So the point being that if I have a corner like here, this should not count as a collision because I didn't like collide with anything visible.
Right.
So that's why we like our pixel perfect collision, because it lets us do stuff like that. And that was kind of tough for people to grasp. I hadn't come up with my favorite way to explain it yet, and it was just honestly a very strange and abstract topic to begin with. The new topic is different. Yeah. And I think, Japes, you like had to ask me a couple follow-up questions because it was like, what is going on?
I asked you a lot of questions, and I don't even think I fully understood what you were trying to do last time.
Yeah, and then I talked to my friend after the stream, and they had also not remotely understood what I was trying to say on stream. Even after you asked all your questions, and you understood it, everyone else was still confused.
Oh, and I pretended to understand it.
All right, of course, of course. So wait, but like, is that a better explanation? Does that kind of make it click?
That makes it click a lot more, yeah.
Okay, yeah. I hope people.
I guess my
yeah.
My only thing was like, why would that be like necessary to do all those transformations?
The point is, if I have a guy that's perfectly upright like this, and I want to check each next pixel, simply adding 1 gets me the next pixel. I don't have to add like 0.38 because it's been like shrunk a little bit.
I see. Okay.
And crucially, if I have something rotated, if this is a rotated rectangle, the coordinate space looks as follows. I actually, in order to move in the x direction, this is the x direction, right? I actually have to add a little bit in the x direction, and because this is moving upward, I also have to subtract a little bit in the y direction. So like the math just gets super messy.
I see now. Okay. That makes a lot more sense.
Yeah. So that makes the math cleaner, right? That lets us do less things. Mm-hmm. But there's another little trick, and this is the latest thing I tore all of my code out for. And I want to give you guys a little bit of background first. So I'm going to show you how like screen rasterization works. And I'm throwing a big word at you, but basically this is how your computer takes an image, allows you to rotate it and do all kinds of other nonsense to it, and then draw it to the screen correctly. Okay, so rasterization is effectively drawing pixels to the screen based on another image. Or like, not really. Rasterization is literally turning a vector into pixels, right?
Right, yeah.
I don't know why I did that. Staircase. Oh my god. This is rasterization, where you're like, okay, I have a straight line, and I need to figure out which pixels I should draw in order to make that line appear on screen. That's rasterization. But the way like the game works is it'll first draw a rectangle. Well, the way your GPU works is it'll draw a rectangle according to your rotation and scaling and position, and then it will decide based on this rectangle where the pixels from the original image should go, right?
So it does it behind the scenes before actually drawing it to your screen, and then it decides, okay, how do I actually make the pixels to put it onto the screen?
Exactly right, and that's a GPU thing. So I'm sending the GPU the image I want to render, and all of the transformations associated with that particular render. Right?
Okay.
And so in reality, so like this rectangle has been rotated, but if I was drawing a pixel, I have to draw it upright, right? So I have to figure out how to draw each of these pixels so that it makes sense. And I'm not doing a fantastic job here of drawing the same size pixel, but hopefully you get what I'm saying, right?
So you have to do this in your engine?
No, this is a GPU step. I'm talking
Oh.
to you about GPUs. This is
Okay.
background for the algorithm that I came up with.
Okay.
So it was inspired by this step. And what really inspired it, so here's the important part. There's a few passes. So the first thing we do is we figure out what this rectangle is, okay? So it's got 4 corners. It's 2 triangles in the GPU, but let's just call it a rectangle for now. It's two triangles though. And what the GPU has to do is decide which pixels on the screen will represent this rectangle, okay? So it's going to get a full list of pixels that go into our rectangle, all right? So like this pixel out here is not going to be in the list because he's outside the rectangle. But this pixel, 100% in the rectangle, in the rectangle, in the rectangle. We get to the edge and it's like, this is in the rectangle. This is, maybe we'll decide to put that in the rectangle. This one's in the rectangle, right? It's every single pixel in the rectangle.
Mm-hmm.
Okay? So, notably, if you were to take a sprite, and let's say this sprite was stretched out 2 times, if you were to simply translate all of the pixels in this sprite into the rectangle here, you would have gaps because you stretched it out by 2, and there aren't enough pixels to accommodate being twice as wide, right?
Oh.
Yeah, weird. So it's literally like, this is 10 pixels wide, but this face here is 20 pixels. You don't have 20 pixels to distribute. So if you just loop through all of the pixels in your original image, you're not going to draw all of the... Well, if you just loop through the pixels in the original image, your end result is going to have holes in it.
Yeah.
Yeah, like these holes.
Because it's not just going to automatically draw more pixels for you.
Exactly right. So here's what we do. First, we find the complete list of pixels that are part of our raster. We look at them. We apply the inverse transformation to this pixel. So that's undoing our rotation. That's undoing our scale. And that's undoing its position in world space, putting it back to 0, 0. So whatever it takes to undo those things, we also apply that to this pixel.
Oh.
Okay? And that puts this pixel somewhere in the original bounding rectangle of our image. The original image. Somewhere in the original image. And then,
Wow.
if we pick the closest pixel, it has to choose a pixel. It can't be a hole. The closest pixel is something.
So, and this is how your GPU works, to be clear.
That's right. This is a GPU operation. You don't have to know how this works. I don't have to know how this works. That's what happens. It is a bunch of old
Right.
iPhones. Thank you. Thank you, Bunny Squeegee. You're correct about the bootleg iPhones. This is my new iPhone. It's got a camera here and 2 half cameras here so that you can take half a picture. I don't know, dude.
No, see, they redesigned the screen to have little, like, divots in it so that you can, like, fully wrap your 2 fingers around your phone.
You're right, and that way you won't miss any, like, TikTok because
Right.
those pixels don't exist in the first place.
Oh, we gotta contact
it.
Apple.
You
gotta contact Apple.
I'm gonna contact Apple about them destroying my phone. So then I started blasting. Right, so we must choose a pixel. This happens in your GPU, regardless of you knowing about it. And it makes it so that there are never any holes in your image, no matter how you stretch it out or do whatever to it. Because every pixel has to map to something.
Okay.
Cool, right?
And then you thought, let's put that in the engine.
Yeah, and this was an idea I was playing with for a while, but I didn't know how to do it right. And then it hit me, like, finally. So this is what we're doing. There is an overlapping area between these 2 images. And to be clear, this is already something that I do, is get this overlap area.
Right.
Previously, I would take my reference object, and I would draw a rectangle around the overlap area. And that turns into my special rectangle that I can just, like, add 1 to instead of having to do this mess from earlier. Remember that?
Yes.
So that's a special rectangle that is now fully upright and axis aligned. That makes it super easy to loop through it and perform per pixel collision checks. I'm no longer doing that. I am now drawing an upright rectangle according to the screen coordinates. See the difference there?
So you don't have to transform the sprite at all?
Still got to transform the sprite, but we're kind of getting there. So it used to be I would choose one object to be my reference, and the and he would get zeroed and everything, and the other object would just follow those transformations so that relative to the original guy, he's in the same spot, but now it's easier to loop through, right?
Yes.
Now, this rectangle is my reference. Or rather, both objects are my reference, and I'm transforming the rectangle to match my guy. And this is where the GPU analogy comes in, right? So what I'm actually going to do is I'm going to look at a pixel here, and I'm going to map this pixel to this guy, figure out, is it transparent? If it's opaque, that means we hit a pixel. And then I go to this guy and I say, are you also opaque? And if they're both opaque, then we've got a collision. And it's impossible for there to be visual gaps because it's the same resolution as the screen you're viewing it on anyway.
Neat.
Yep. So, sorry, I missed a few things. So
I see the vision. I don't fully understand, but I see the vision.
So the issue with the previous algorithm was if you had a big scaled up object with gigantic pixels, our relative guy might have like 3 pixels here, and that would be the entire thing. So like this is like a times 10. The red one would be like a times 10 scale, and it's this big rectangle. And the orange one would be like a times 1 scale, and it's literally just 3 pixels. That's the whole sprite. And this would not register a collision because all I can do is check for the top left corner of this pixel, and then the top left corner of this pixel, and the top left corner of this pixel, and so on. And we would actually just miss this sprite because it's too small.
Right.
But now, if this sprite is getting drawn to the screen at all, we'll catch it.
Okay. So I guess that little simple solution I gave you about scaling didn't really work in the long run, did it?
Which one?
The one where you were like trying to explain some stuff to me, and then I was like, well, why don't you just factor in the scale factor into this sort of thing? And you were like, oh.
Oh, that's something totally different. That was for locating
okay.
these corners.
Oh, okay.
Yeah, I still use that.
Nice.
Yeah. Although I might be able to phase it out, but I've been thinking about it. And it's like, I think it's just not worth doing, is the thing. I already pre-compute that stuff, so it's not wasting any more time. And it gets me the exact coordinate of the end pixel, which I really like having.
Doing what exactly are we talking about here?
So what you were talking about is it would find, if you had the edge of a rectangle here, it would find the last singular pixel on that rectangle.
Okay.
That's what we were looking for before.
Oh, yeah.
And
yeah.
I like having that.
Okay.
So I'm going to let that be for now.
Okay.
Anyway, yeah, so this is the new algorithm, and it's honestly ridiculously simple. The other algorithm was kind of spiraling, and this one's just clean. That's what I can see. So if I open up collision, I can literally show you the entire algorithm in like 2 seconds. It's so easy to grasp now. So check it out. Having shown you that, first thing we do is we get our bounding shape. So let me make this small so I can point at things as I go. So no. So first thing we do is we get our bounding shape. So that is in blue.
You could just put the whole paint window to the side of the screen, right? Oh, that wouldn't work.
Anyway, yeah, I could kind of do that, but I think this is better for now. So this gets me this shape. This gets me all the vertices in the overlapping shape. So in this case, a triangle, I have 3 vertices. Okay?
Mm-hmm.
And I don't know if this is something I can fix, but as it stands, I don't think it's something I can fix. I don't think it's something I want to fix. I think it actually saves me some steps. But as it stands, that is giving me this shape relative to a reference object. So I do have to perform a transform to get it relative to the screen. Then, this circumscribe vertices with axis aligned bounding box outputs a rectangle. So that gives me this red rectangle. Okay. And I give myself a little bit of buffer, so I'm making the X direction wider by 1 pixel, I'm making the Y direction wider by 1 pixel. And then I'm just looping through the left and right side of the rectangle, and then the top and bottom side of the rectangle. And in this loop, I take the current screen pixel, I transform the current screen pixel relative to object A. I'll get to this in a second. I'm going to skip that for a second.
Yeah.
I'm going to check if the pixel is even in the bounds of the object in the first place. If it's not within the bounds of the object, then that means that we're no longer worried about it, right? And then I'm simply going to check in the color array. So this is an array of colors. I'm going to check in the color array. Is the opacity less than the cutoff? If it's less than the cutoff, we got to continue because that pixel is not going to collide. Not going to collide with anything. And this is a really simple... This is the equation for getting a 2D coordinate out of a 1D array. So it's like the x position of the coordinate, the y position of the coordinate, multiplied by the supposed width of the 2D thing, right? Like, should be familiar if you're if you've worked with this stuff, but I can explain it in a second. Point being, this just gets the correct color. You can ignore this formula. It gets the correct color out of the array. Yeah. Or it gets the correct pixel out of the array. And then the one fun thing is if you do a sprite flip, normally when you have a pixel and you have like a dot here, in order to figure out which pixel it is, we just move it to the top left corner. So this would be like 0.9, which like let's say it's 0.9 comma 2.3. That is going to map to pixel 0 comma 2. That's just how it is. Right?
Okay.
If the sprite has been flipped, then we need to map to the top right corner. So that would be...
This only matters when we're scaling stuff, right?
This is for flipping sprites. So, like, literally mirroring them. Like, if you had a player walking left and you wanted him to turn around to walk right, you would do a sprite flip. And we need to be able to detect that kind of transformation as well.
Okay.
So it's like the pixel's literally turned around. So the top left corner is no longer the location of a pixel. It's now the top right corner if I flip in the X direction. If I flip in the X and Y direction, the coordinate of the pixel is actually its bottom right corner.
Right,
So
and it doesn't matter if we've scaled it or not, that there's always going to be a location of a pixel because our code can do more precise math than pixels on a screen.
Exactly. And that's the problem with like floats, because pixels would be represented as integer values, and we can have decimal values, like floating point values. So it's like 0.5 doesn't map to a pixel, so we need to either drop it to 0 or increase it to 1.
Right.
So if there's no flips applied, then we're always going to drop it to 0. But if there are flips applied, then we always want to increase it to 1.
Right.
In that direction.
Makes sense.
So it's like for this guy who's only been flipped in the X direction, instead of 0.9, 2.3 going to 0 and 2, it would go to 1 and 2. And if it was flipped in both directions, then it would go to 1 and 3.
Okay.
And that actually gets us the correct pixel. Yeah, which
Cool.
is kind of messed up. But that's what I had to do in order to get flipping working. So anyway, so all of this is to check for an opaque pixel on object A. It is duplicated to check for an opaque pixel on object B. And if we pass all of these conditions, we have 2 opaque pixels overlapping, and we can return true.
And that
And if-
means collision.
That means collision. And if we never get here, and we get past all of our for loops, double nested for loop, then we return false.
Cool.
That was a lot.
It was.
But it's really like just a couple of things. It's the overlapping shape. Yeah, it's the overlapping shape. It's the bounding rectangle on the overlapping shape. And then we're just going to, for each pixel in the bounding rectangle, map it to each of the 2 objects and check if there's an opaque pixel. It's like 4 things.
Okay.
And it's like, we can instantly make this faster. Because I'm already, like, I didn't do something important. And that important thing is just checking if there's a remote possibility. I'm not even checking if the 2 rectangles are overlapping in the first place. Right?
Oh.
Yeah.
Well, that seems like it would save a lot of time.
It would. So we're going to go for this. This is our separating axis. Separating axis theorem. So yeah, the Sutherland-Hodgman is slower than separating axis. So we're going to do separating axis first. If they are not colliding according to the separating axis theorem, we're just going to immediately return false. We're done.
Okay.
Yep.
There we go.
Yeah. Yep. There we go.
Does that mean that the tower might be able to simulate more or handle more collisions?
It very much could mean that. Because we're running the clipping algorithm on every single object pair. And that's silly. We don't have to run it unless there's a chance for collision. So here it is. So here it is running right now. Took a second for it to smooth out, but it's
Right.
good. Let's go back to our VHS scene and start to increase. So at 70, it still couldn't handle it. Let's see what 70 does. And this might be overkill for a bunch of upright shapes. It's really, your cost saving comes from when they're rotated.
Right. But we like to go overkill so that we don't have to worry about it in the future.
Well, what I mean by overkill is that it's more checks that are necessary. So, like, the fact that it didn't make this smooth out isn't a huge surprise.
I see. Because we shouldn't really need to be checking for them because none of them are rotated, is what you're saying.
Well, not only that, but, like, so the clipping algorithm, for example, we don't even have to run that. If both objects are upright, then it's just a rectangle.
Right.
An overlapping rectangle, and we can get, like, it's the smallest right and the largest left and then the largest top and the smallest bottom of the 2 sprites gives us the overlapping rectangle, which I know that's really hard to visualize in your head. But point being, it's literally just 4 checks to get all of the edges.
Yeah. Well, wouldn't it be fairly easy to like take the data from the sprite and be like, hey, is this rotated? If so, then we'll run the fancy code, and if not, we just won't worry about it.
You're right on the money. Yes. And that is what I have commented out here. So I have all these collisions. I have, first of all, if the angles are 0, then we're running all of the different cases. And then if the angle is not 0, we're going to run all these different cases. So yeah, yes, you're absolutely right. I just haven't gotten to do those efficiency improvements. I was just getting the general algorithm working.
I see.
But now that it's working and we're happy with it, I am going to kind of like make it totally efficient, like what we need to do before I move on.
Okay.
So what does that mean? That means kind of following down the path, well, following the road, and deleting a lot of functions and methods that I really just don't need anymore, and like just cleaning up the code. So this is a brand new, I just pushed this to Git before I started the stream. So we're gonna start tearing this apart.
Real quick. Funny Squeegee said Japes could make a podcast where he explains science. Somehow he sounds really authoritative. I think that'd be so funny because I really don't. I really don't understand. I mean, I do enough, but I could never come up with this stuff.
They think you could easily become a dictator. Oh boy, you have the voice of an expert. I want you to repeat everything I said. Don't worry about getting any of it wrong. Just sound super authoritative.
Yeah, so by the way, this little piece of code right here, you won't believe it, okay? But this actually will turn you into a femboy if you run it.
Wait, really?
Oh yeah, try it.
Okay, I'm down. Wait a minute. It's gonna turn me into a femboy.
Too late, bud.
Yeah, so I don't know if it worked.
Oh my god! I was wondering where you'd go with that. Oh, I cringe.
No, the worst part is on another computer, I built a voice changer for like a feminine voice, and I just didn't have it ready to go.
Why did you do that?
The actual reason is I saw. What was this? It was like back in 2022, I think, ish. No, 2020-ish. When. What's his name? Gosh, the EDM guy. He did all the Miku songs. Wow, I'm not making this better for myself. Porter Robinson. So Porter Robinson put out a like concert compilation video, bunch of his songs, whatever. And at some point during the concert, he sings with like the most feminine voice. And it's clearly, I think it's a combination of him just being an insane singer and knowing how to do that, but also like a voice modulator that he built. So I wanted to like see if I could also build it because that was super cool. And I got it working really well. It's not like convincing, but when you hear it, you're like, wow.
I was gonna say, like,
yeah,
bro, just skill issue. You had to go to software for that. SMH, just do it with your real voice.
I know. One day
I'm not the best at it.
One day I'm gonna break that out, and everyone's gonna be like, "Oh my god, is that a woman?"
A woman programmer? Marry me now.
Oh no. Where are we at? So I'm gonna walk through this step by step, and you're all gonna like it. First off is this boy though. So yeah, I am taking the initial 4 corners and performing this transformation on it, which seems like kind of a wasted step if I'm just going to untransform it later. But also, if we go to like this orthogonal clip, the fact that I have a vertical or horizontal line that I can rely on makes this much simpler. So I think I'm going to leave it.
Okay.
I'm going to leave that for sure. Okay, then we've got this. So like this circle has pixel perfect overlap. This is using the old code. I'm going to use the new code later. So he can just go away. It's like, goodbye. Nobody needs you.
Okay.
Well, goodbye. Rectangle has pixel perfect overlap. That's the old code. Goodbye.
You sure you don't want to save this somewhere?
No, that's what I was saying. This is a fresh Git pull. Everything is on Git.
Ah, I see.
Plus, I barely work on the tower anymore. I mostly work on my laptop, so it's especially safe. I only work on the tower for streaming.
Right.
Which is always... Nowadays, that's a bit of, you know, that's a little scary. It's a little spooky. Because the tower can't handle the latest version of .NET, and I don't know if I'm going to accidentally do something while I'm working on my laptop, and then try to stream, late as always, and it just won't run, because I've got .NET issues.
That's part of the appeal. It's part of the vibe.
Part of the vibe is getting into a stream 15 minutes late, and the guy's still not set up.
And then the software that worked on his other computer just shits itself. Oh, sorry. Can't say that.
No, you're okay. That's why I need a Docker.
Oh, that's a good idea.
No, it's not.
Sure it is.
Right. Okay. Pixel Perfect has Pixel Perfect overlap. I don't think I'm using this anymore either. AABB has Pixel Perfect overlap is kind of insane.
What?
Axis Aligned Bounding Box and another Axis Aligned Bounding Box have Pixel Perfect overlap.
That's a pretty crazy function name there.
Thank you. I made it crazy myself.
I'm gonna call it Abba Abba.
That's
And then
a
I'll
good
just
idea.
think of the song Money Money from ABBA every single time I think of that function.
Money.
I think it's just called Money. I don't remember.
Anyway, this I said remove when everything works, but now that I'm going in a totally different direction, I'm just going to remove it, because guess what? Didn't work. I'm certainly not using that. This is my old Pixel Perfect collision code. It's kind of a mood. This was like, light mode, this old algorithm that this guy had back in the day, but I'm no longer using his algorithm, so you
Sorry,
will
Michael Hicks.
always be in my heart. No, that's not Michael Hicks. Michael Hicks is
I
the
know.
game engine guy.
I know.
Dude, no, this stuff's crazy though. 2011.
Oh wow.
Yeah.
Man, that's right when C# was like first implemented.
Yeah, that's the very beginning of C#. No, it's not.
What?
That is not the beginning of C#.
That's not what I said. I said that's around the time that they like started.
I thought you were talking about like F and A. X and A release. Wow, why is this so terribly
It's
unhelpful?
wrong.
Yeah, like... So XNA apparently lost support in 2014, so it's like close to the end of life for XNA when that was published. But anyway, yeah, so unfortunately I'm no longer going to be crediting this guy because I'm not using their code, but in my heart I'm still using the code. Oh my gosh, look at the length of that method. Or
You know,
look at the
he
number of
helped you.
algorithms.
He helped you on the journey.
He did. I'll never forget him. I'm gonna forget him though.
Yeah, ultimately.
Which means this no longer has relevance. We're gonna get rid of you. Bye. Unfortunate. Orthogonal clip I still need. So let me just do like a quick control MO. Orthogonal clip we still need. Sutherland-Hodgman rectangles we still need. Sutherland-Hodgman rectangle GJK we still need. This is rectangle, and then rectangle GJK. So like how does GJK one work though? Oh, okay. It has to be an upright rectangle. That's... Yeah, so I'm still relying on upright rectangles. That doesn't go away. GJK, by the way, means just like a generic convex polygon. GJK is any convex polygon. Or GJK is the collision algorithm for two convex polygons, but you get the idea.
Convex pop. Okay.
Circle and rectangle overlap area. This is gonna change, so I don't know. Like, yeah, this was intended for. I'm just gonna get rid of it. This was intended for like after you inverse transform the circle according to the rectangle transforms. it could like get squashed, so you end up with like an ellipse. But
Mhm.
we're not doing that anymore, so I'm just gonna get rid of him. Goodbye. Didn't ask. Goodbye. Okay, and then axis aligned bounding box overlap area. This is what I was talking about. This is the minimum overlap area if you have two upright rectangles. So this guy's important.
And we're working on to recap. We're working on making the current algorithm more efficient. Correct?
Yeah.
Okay.
Well, no, we're cleaning up our code because I ripped out the previous stuff.
Okay. Okay. So we haven't gotten there yet.
Yeah, I'm making stuff cleaner so that it doesn't turn into a giant mess as I keep doing that. And then circumscribe vertices with AABB. I don't know if this is popular belief or not, but circumscribe does not necessarily mean using a circle. Circumscribe could be any shape. So in this case, we're circumscribing all those vertices with an axis-aligned rectangle. And then we get the top left and the bottom right of a rectangle that contains any set of axes that we give it, or any set of vertices we give it. So that's everything for the texture collisions. Yeah, his class just has all these static things.
Okay.
And because I'm nice, I made it publicly accessible for you to get these things. Like, well, yeah. I made it publicly accessible for you to get the clipping data if you have collision matrices. Because I just, why not? On the off chance that you actually need to use that.
Right.
AABB overlap area, I'm not going to make public because that's kind of specific. And then circumscribe vertices with AABB, I'm also not going to make. I could make this public. It's not actually anything specific. It's also technically something very simple, but whatever. It can be public. And anything public just means that I'm allowing like end users to put it in their game. So
Right,
you can utilize these couple of methods in your game, basically. Okay. So that does it for texture collisions. That's really good.
Nice.
Next, we're going to go into our collision matrix. And this guy's got a ton of useless stuff in him because I'm no longer using a handful of values. So like this is all gone. Well, there was something to test, I guess, which was pre-computing cosine and sine, and then rather than having this step where I calculate bounds and matrices and blah blah blah, I was going to have a simpler equation that just did it on the fly, but it's not as simple as just doing like coordinate transformed by matrix. So I think effectively this is still just better.
Well,
Yeah.
what would be the benefit of doing it on the fly?
So the benefit of doing it on the fly, so this is doing is it's calculating the faster. So if I have a transformation matrix, it's really fast to transform a single point. Okay.
Okay.
It's only a couple of additions and multiplications. If I don't have it, then I have to do. I have to subtract the offset of the texture. Then I have to perform rotation, which requires 2 cosines and 2 sines. I'm sorry. I have to multiply it by the scale. Then I have to do rotation, and then I have to move it again. Right? And it comes out to like 20 operations. It's not nearly as expensive as putting together the matrix, right? But
Is it?
I have to do it every single time. It's much faster than putting together the matrix, right? So if I already have the matrix is the fastest thing to use. But putting together the matrix is really slow.
Right.
So what I have here is this if dirty. Dirty is true if the translation, scale, rotation, or flip change. So if anything about the position of the object changes, we need to recalculate its transformation matrix.
Ugh.
But in the case we just saw where I have 70 objects bouncing all over the place, you only have to do it once, and then it's good for 69 more checks.
Right.
So, and then if you only are checking one thing per frame, it's not that big of a hiccup to have to deal with. So the thought process was, if you were updating your position like every single frame, which is not unusual, then you'd be recalculating this matrix a lot. But the fact of the matter is, where you want your savings is when you're doing lots and lots of calculation, lots and lots of collision checks per frame. And in this case, just calculating the transformation a single time is definitely faster.
Yeah.
So
That definitely sounds like doing it on the fly is the worst option.
right. Well, the thing is, doing it on the fly is a little bit faster, but every time you add a new object to check, you lose savings.
I see. So it's faster up until a point.
Right. And the problem, well, and the thing to think about is, like, up until a point, is that point before the game even slows down in the first place?
Right, exactly.
And if it is, then it's actually just pointless.
Yeah.
Then we don't gain anything. So that's what we're doing here. So I think I'm going to leave that. I feel like that's correct. So actually, let's just go down the list here and see what we're using. We're using the width and the height. We're using position. We're using scale. Oh, you know what was crazy? So all these vector 2s are expensive.
Yeah.
Like, actually.
Oh, yeah.
They be expensive. I have in my game object. Oh my gosh, he's not happy with me because I just got rid of all the stuff. That's not a surprise. It's because I got rid of all my old methods. I had here in public properties under image scale. Actually, no, it was in the sprite. Okay, in my sprite, under image size. Here. Under image size, instead of having a get and a private set, I had like get, and then I was doing new vector, new vector 2, and then that would be sprite width and sprite height. So I was just assembling it on the fly. This was eating an enormous percentage of my CPU usage, like upwards of like 15%.
Oh my gosh.
Just because it gets called constantly during my collision checks. So just pre-computing it and pre-building that vector 2 saved me so much. It was crazy.
Nice.
So benchmarking is wild. Would not have caught that if Tuesday hadn't forced me to benchmark. Thank you, Tuesday, as always.
Thank you, Tuesday.
Thank you, Tuesday.
They've got all the answers.
For real. So texture offset is fine. Collider offset is fine. Sprite effects is fine. Collider top left is fine. Bottom right is fine. Minus inversion. Yeah. Flip and scale. Inverse flip and scale. Oh, do I actually need all of these? Apparently I do. Okay. So we can start removing this commented stuff because we're never coming back to it. Oh yeah, this was the original. This is what I would do instead of pre-computing a matrix. So it's like I subtract the position, I subtract the position with top left correction, then I would perform a rotation, which is all of these calculations, and unsign and uncosine just means negative angle.
Right.
Which is different from inverse sine and cosine. Perform the inverse of the flipping, add the offset. Yeah. Whereas with a matrix, you would do like, it'd be like value 1 times value 2 plus value 3 times value 4 plus value 5. So it's 2 multiplications and 2 additions instead of all of this.
Mm-hmm.
So it was just better.
Okay.
Oh, that's the thing I can get rid of. I can get rid of this int transformation thing. Let me just collapse some of this stuff. Music is kind of good right now. Yeah, this int transform can just go away, along with like int width, int height, all that. So what that was is, I was checking if we were using integer transforms, and if we were using integer transforms, and everything was an integer transform, then I could, if everything was an integer transform, then after I performed my matrix multiplication and all that, I was going to round it so that we wouldn't get hit by floating point errors. But this was actually causing me problems because the new way I'm doing things performs that like extra offset helper thing. It actually does that right here when I'm doing like my ceiling or floor. So by rounding it early, I was having actual issues.
Ah. Okay. Makes sense.
And it's good because that saves me things to pre-calculate. That saves me things to check every frame. I don't mind.
Mm-hmm.
Let it die. Bye. And now I
The
have
more
to go
efficient.
to exactly. I have to go to all the places where I was pre-calculating it and get rid of it.
That's why it's so mad at you, isn't it?
Yeah, that's why I turned red. All I see is red. Yeah, you can see what it is. It was like, if the integer position of x is equal to x, then yeah, that's what we've done.
Right.
So int scale needs to go away. Integer angle needs to go away. And this is like, so this is an interesting one. See, because int angle actually kind of is a thing. Because if it's rotated 90 degrees, 180 degrees, or 270 degrees, I can apply the same cost savings as I would have if it was rotated at 0 degrees. But I'm going to save that exercise for when I actually get there, just so that I have a clean slate when the time comes. So this we can do that on. Glider offset also has an integer calculation. You can see there's a lot of these.
Mm-hmm.
Makes sense. Sprite effects I don't think has an integer to worry about. And then right here, so int collider offset, we're not worried about. Perform transform. Right. So this is important. Our perform transform was asking if we should do an integer transform, and we don't want to do that, so we need to get rid of that completely. And in fact, this perform transform doesn't do anything for us anymore, which is a little sad.
Did you come up with that, or?
Yeah, so the idea for this was back when I had integer operations, I would do the transformation and then I would round it. And I made it a method because I was doing that a lot. But
Yeah.
The reality of the situation is now I'm not. Goodbye.
Bye.
Bye-bye. Have a wonderful time. Yes, like, okay, so it's my special vector to transform. So I'm going to leave this. And actually, right, so these are private. So that's actually fine. This is a little more interesting. So this is going to check if we're dirty and recalculate all our transformations. Okay?
Mm-hmm.
Then we need to perform our transformation, and that is something different now. So it's going to be, this can all just be done in line, systemnumerics.vector2.transform. And this takes a handful of different things, either a 3x2 matrix, a 4x4 matrix, or a quaternion. We're not going to use a quaternion because we don't.
What's a
hate ourselves.
quaternion?
Oh my god, did you just open a whole can of worms?
I've never heard that before.
I'm going to save the entire stream and just say don't worry about it.
Well, now I'm curious, but I'll trust you.
Okay. Just to make you more confused, a quaternion is how you handle translations and transformations and rotations in 3D space, and crucially, it avoids gimbal lock.
More things I've never heard. Gimbal lock sounds like a European, like
Hey,
folklore
careful.
folklore character.
Gimbal lock. It's my
He sounds like some
character.
gnome from England. Like,
Sir
and then
Gimbal lock.
what was the Quay whatever you said?
Quaternion.
Quaternion? That sounds like a Roman position in the army.
Wait, why are you right? Don't be right about these things. Okay, this takes a reference vector to... Right, this takes a an FNA vector too, but maybe I shouldn't do that. Because like we said, like this is expensive, right? This is a new vector too, and if we end up reusing stuff, so let's make this a system numerics vector too. I'm probably gonna regret that, but who cares?
You might later. Who knows?
Asked. Anyway, we're just gonna return. We're not returning anything, crucially. And now I don't need to build a new vector 2 because we saw how expensive that is for some reason. Ooh, exciting optimizations. Okay.
Hey, I find it kind of exciting. Like
I
we haven't
appreciate
done
that.
anything with we haven't done anything with it yet, but like the more efficient we make it, the cooler it is, you know?
Yeah, and I mean, like they say, premature optimization is something, but the faster we make the underlying like collision engine, the easier it's gonna be for end users, and they'll say, "No, I
Right.
don't use GameMaker. The collision's too slow. I use Enable."
Yeah.
By the way,
I
the
don't
game's
think
called
it's-
Enable. Also,
Yes.
by the way, wow, I was about to tell everybody to like the video and subscribe, and like especially the subscribing part,
Mhm.
and we just lost 3 viewers like that. Like I didn't even say it yet.
They read your mind.
I saw we had 6 people, and I was like, "Hey guys, subscribe." No, gone. Goodbye. We don't
Well, you
like
do know that like it's just random people probably.
Exactly.
click
That was
on
my
it.
chance. That was my chance to tell them to subscribe. Hey, you person that just joined, subscribe. Thank you. Anyway,
I wouldn't worry too much about it.
I'm not worried. They know what'll happen if they don't subscribe.
Oh, that's ominous.
Slash threat. Okay, so then when you so we're going to
And then I can fly everywhere.
transform position vector 2 stop it's lowercase vector 2 inverse transform why are you mad, dog? Why are you mad, bro? No, I actually wasn't mad though. You are not a system numerics, that's why. Okay, it's happy, and I can get rid of all this. Yeah, the code's actually cleaning up really intensely. Okay, so these are not vector 2s, right? So the question is, do I troll the end users by making these actual C# vector 2s?
No. The question is, do you want to troll your end users? No, no, no. This isn't I want to make a game.
The thing is, it's not really a troll because they don't have a good reason to use this stuff. Like, I could make this internal and no one would notice. But it's like system.nim. Basically, instead of using the X and A vector 2, I'm going to use this C# built-in vector 2.
Because of course there's 2 vector 2s.
Yeah, People like re-implementing Vector 2 for some reason. And just, like, numerics in general. The problem is... Yeah.
It doesn't matter. I was going to make a joke. Go on.
Oh, you're good. The real problem is that this is supposed to port directly from XNA, so they have to use an implementation of the old Vector 2. However, C#'s actual Vector 2 takes advantage of hardware acceleration, where we can do multiple operations simultaneously.
Ooh.
Yup.
I'm gonna go get more water real quick.
No,
I'll
you
be
won't.
back in a jiffy.
No.
Okay, well you're gonna have to pay me double if you're forcing me to do that.
I'm gonna pay you half.
Yeah. You know that works too.
It's all the same.
But
to
still good.
you. All right.
All right. Be back in like a minute.
No worries. Okay. So if you... Oh yeah, if you calculate the position offset, we do need the correct version. So this needs to be an actual vector 2. New. Or sorry, position needs to be an actual vector 2, so I'm going to have to generate a different vector 2, but this is only going to happen whenever you update something about the sprite, which, like, you shouldn't have to do more than however many types of transformations there are per frame. So if you're setting if you are setting the horizontal or vertical flip and the rotation and the position and the scale every single frame, this will only get called 4 times, which doesn't even come close to the number of times that image size was getting called when we were looking at sprite earlier. So I'm not worried. Although it would be nice if these were implicitly cast. I guess I could update it to be implicitly cast, but I won't. I'm not going to do that. And then this is all system numerics vector 2, and this is a system numerics vector 2. And what could you possibly be upset about? Because this is not a system numerics vector 2. Vector 2. New. Oh, wait, the new goes over here. New. Vector 2. Position X. Position Y. Position W. Position 3.5. And then we go here, and this is all wrong. Texture offset. Collider offset. Is there any reason on the planet for these not to be? Nope. These ought to be special vector 2s. So system numerics vector 2.
I'm back.
And this is a system numerics vector 2. What's up, dude? I'm just out here, like, genuinely
Cleaning.
losing my mind. Yeah, that's probably going to become a system numerics vector 2 in a second.
Genuinely losing your mind. Yep. That tracks.
It tracked. You can be a system numerics. And you know what? Everybody's system numerics now. Everybody gets one. Everybody gets to be system numerics.
You get a system numerics. You get a system numerics.
Exactly right. You get a system numerics. You get a system numerics. You get a system numerics. You get a system numerics.
I cannot wait for the weird ghost bugs that are going to come about from this little cleaning session.
Funny thing about that, though, which is nice, is that system numerics is... Vector 2 works identically in both libraries. It's just that you can't, like... You know what I mean?
Oh yeah, but there's a lot of other stuff that we've done too. I'm not worried about the Vector 2 stuff.
Oh, actually, the methods that I deleted are actually not being used anymore. Like they just will not get called.
Mm-hmm.
Mm-hmm. What, you don't believe
And
me?
they're-
Huh? Huh?
It'll always work first time, every single time.
I didn't say that.
Hmm.
This is a little annoying. I gotta find all of these. Okay. Oh, gotta come back up here now. Yup. And then this can, once again, just be position. That's gonna save me. One calculation. Yep. Once again, exciting optimizations. And you, Vector 2 transform not dirty. Where'd you go? Oh. I may have accidentally deleted something.
Oh no, who could have seen this coming? Sorry.
I mean, it's not a ghost bug or anything. I just deleted one too many things. I don't remember deleting this though. That's the weird part.
You know, honestly, I don't remember you deleting it either.
Well, that's fine. So this needs to be system numerics, and this needs to be system numerics. And then I'm just gonna pull up GitHub and grab that function.
Good old GitHub.
I'm currently logging into GitHub off screen because y'all don't need to see it. Oh, I think I need to opt out of a bunch of things on GitHub that AIify my code, which is really exciting. Or maybe they're using my code to train AI.
That's
They can genuinely kill themselves. Like all of the drama in the world for me saying they can kill themselves, they can genuinely kill themselves.
cow. Going strong. It's okay.
I'm,
We only have 2 watching now. It just went down.
I'm literally correct. I think 3 people on the stream just have wacky internet.
I mean, I have wacky internet sometimes. It's only messed up once during stream. I'm happy about that.
What's only happened once? I'm sorry.
My internet dying.
Oh yeah, you actually barely even went away. You were kind of fine with it, so no worries. So okay, let's go back to engine. This is in the collision matrix, so let's go to collision lib, collision matrix, and then this is going to be transform not dirty. Oh. I was meant to delete this.
Oh.
Yeah, all this does is perform a transformation without calling this calculate bounds, which means it's just doing this. It does not need to be a function.
Okay.
So this is going to be him is equal to system.numerics.vector2. We're going to be using him and our transformation matrix. Wait, vector2 dot transform. No, like I said, using him and our transformation matrix. Why are you mad at me? Don't be mad at me. I'm just a girl.
Just a teenage. Oh. I almost started singing.
Why? Just why? What's it mad about? Okay, inverse transform. Wow, that was really weird, because even when I'm literally hovering over it and it's not giving me any context help. Do I need to restart Visual Studio again? Man,
That is a little
freaking
odd.
program used to work, actually, and then Microsoft said, this works too well.
That is the story of Microsoft in a nutshell.
Before you is a perfectly good wheel. The door is open. You must leave the room. Do not reinvent the wheel. The door is open.
So my old retired coworker that I know I've mentioned to you at least once.
Yeah, last time you mentioned they weren't retired.
Right, yep. Well, no, they're semi-retired.
Oh, that one.
Yeah. He's been working with computers since they were essentially like invented. Not really, but like for like public use, you know. And my gosh, if you can get him on a Microsoft rant, he will say the nastiest things about those guys.
Yes, sir. Please. Okay, wait, what? Huh.
Is it not letting you type anymore?
No,
No,
I
it
was
is- oh.
trying to get the IntelliSense menu to pop up. It might just be dead because I have some errors that it doesn't like. But that's silly. Also, it should be
I
telling
think
me
I-
what's wrong with these errors. But I already know what's wrong with them.
I think I remember IntelliSense not showing up because of errors in Visual Studio from the brief time that I messed with it years ago.
Black
But, you know,
Sniper
I could be
says... Oh, sorry, go on.
No, you go.
IntelliSense? IntelliSense?
No, I was just saying, like, I'm pretty sure that, yeah, it doesn't show up if you have errors in your code, but I could be wrong, as I haven't messed around with Visual Studio in years, so...
Well, not even, like, just the IntelliSense, just the error help. Like, I should be able to hover over it, and it tells me what's wrong with it. And him not.
Yeah, that is weird.
Him not doing that. Anyway, Black Sniper says, hello, people. So what you got? Man, I hate Microsoft. Hello, Black Sniper. What we got is a brand new engine in C# that I will be releasing in a couple of months when I can get all this nonsense working. This is super, super fast, pixel-perfect collision code. The fastest you've ever seen. Probably.
I wish we could pull up a demonstration, but you're cleaning up code right now.
Oh, no, this would be... Yeah, there's so much. There's a big mess at the moment. But yeah, on my good laptop, it was running 10,000 pixel perfect collision checks without any of the optimizations I'm adding. So that was really, really good. And then this computer was like 2,500. But it's not necessary, but I like pixel perfect collisions, and I've sunken cost fallacied myself into it. Got a question. Will it be open source? Will it be completely open source? Yes! Yes, it will. If you want to stay up to date, you should totally join the Discord linked in the bio, where you can chat with all the cool people there and also get all the updates as I come out with the engine stuff.
I think it's cool. Like, I don't know. I think it's cool that this has been like years in the making, this engine.
Yeah, it's about 5 years at this point, and it's gone through such tremendous, like, maturity
Changes.
spikes. Like,
Oh,
there's
yes.
just been moments where we go through and just, it's not even fixing things. Like, stuff wasn't broken. It's just better now.
Right. I mean, the whole pixel perfect collision thing has just been like it's been optimized so many different ways. I think, like, I remember when you first tried to do pixel perfect collision, and then it was like slow and all this stuff, and now it's so much faster, and now it's like, how much can we just break this engine before your computer just completely dies?
Yeah, well, the other thing is I just didn't get it. Back when I was using that... So, context now. I said this earlier in the stream, but basically... Hey. Google. Oh, okay. It's not just Visual Studio, actually. My entire computer is imploding at the moment. Wow.
Oh,
I think
Well,
Google's
that's not good.
imploding. I may need to close Google, which is a little annoying because I kind of have the live stream running off of Google.
I think it's still working.
I think Black Sniper just destroyed my stream. No, okay, we're good. We're good.
Just kidding.
All I do is blame people. Anyway, so this was the original collision code. I didn't get it. I really just genuinely didn't get it. Until a couple of months ago when I decided to go back and make the collision code parallelizable. And in order to do that, I also said this is time to make it fast. And I had to learn how all this worked.
Yeah.
And the new strategy is really novel. Here's a big mess. Here's a big mess. But the new strategy, just to reiterate, is... So if I have a couple of overlapping guys... So there were a bunch of like inconsistencies where we would like skip pixels or miss things because like if an image has been scaled up like this, the way we do this is we're going to check every individual pixel on one object and see if there is an overlapping pixel on another object. But in order for that to work, when we check this pixel right here, it has to be inside of another pixel already. Right? So if I have a very scaled up pixel, like this is one pixel, let's say, but it's been like scaled up 10 times, I could have another sprite that's like 4 pixels, like literally just 4 pixels. Like that's an entire sprite right there.
You have a sprite inside of a scaled up pixel.
Yeah, because this pixel's been scaled up so much. All I'm doing is checking this pixel right here. Wouldn't pixel by pixel be memory consuming? Actually, no. And the reason it's not memory consuming is I already have the sprite in memory with the color data in order to load it to the screen in the first place. Does that make sense?
I don't think it makes sense. And I've heard what your explanation is for all of this.
You don't think that makes sense? Okay. So I believe the reason Black Sniper thinks this would be memory consuming to go pixel by pixel is because we have to get the individual color value of every single pixel in the sprite. And that's true. We do have to get all of those values. But we don't have to... The thing is, we're not saving values in memory that aren't already in memory. In order for you to draw the sprite to the screen, we already have to have the PNG loaded in RAM. So sampling the color data of the PNG already loaded in RAM is not going to spike our memory usage. It's already there. So, yeah, we're just getting the color data of the sprite that we are already drawing anyway. And that's not coming from the GPU or anything. That's loaded in RAM is CPU side. VRAM is GPU side RAM. Anyway, so, but
yes.
Yeah, it's entirely possible to have like an entire sprite inside one pixel. And if we're checking this one pixel, we can miss the whole sprite because this top left corner of a pixel isn't in any of these guys. In order to actually like check this, we would have to get the full rectangle of the pixel, like treat it as a full rectangle, and then check every single pixel to see if it was inside. And we'd have to do that for every pixel.
And that would be time consuming.
That would be, as the image got bigger, like more pixels, it would get, it would square how many checks we would have to do.
Yeah.
Because every pixel has to check every other pixel, instead of just one pixel checking one other pixel. So the new situation is, instead of doing that, this was like the old way, this is the normal way to do it, this is the way that you see online, if you look up how to do per pixel collision. And it works great if you don't have a scale, and it works okay if you don't have rotation. But if you have scaling and rotation and image flip and all kinds of nonsense, you can miss a lot of edge case collisions. The new way to do it... Jade, tell him to check chat before my question stops making sense. Oh, yeah, I'm sorry. It is not a 3D engine. This is a 2D engine. I'm sorry. Is this similar to GPU sprite mapping? This is similar to GPU sprite mapping. Or, the way my new collision algorithm works is similar to GPU sprite mapping. So I'm going to show that now. The way GPU sprite mapping works is rather than checking each pixel in the original PNG and mapping it to a coordinate in space. Rather, let me tell you the problem. Sorry, forgot that for a second. If I have a sprite...
I'm a little bit lost myself, if I'm going to be honest.
Because I explained this a little earlier in the stream, so I'm kind of do it quickly. Trying to do it quickly.
Yeah.
But basically, so check it out. I've got a sprite here. This is my original sprite. If I wanted to scale him up 2 times to make him way bigger, if I take every pixel in my original sprite and move it to the new coordinate, I'm going to end up with gaps, right? Because there literally aren't enough pixels to fill a space that's twice as big. This old sprite that used to be 10 pixels wide is now 20 pixels wide. Is the PNG supposed to always be a rectangle? PNGs are rectangles, and there's nothing I can do about it. That's just the file format, if that makes sense. I think Celeste had its own game engine needs, so this would be really helpful for those types of game devs. Yeah, actually, so this is using the FNA XNA framework, which is the same framework that Celeste used. But they made their own engine because they're special. And I'm sure no one will notice that this engine exists and will decide to make their own engine whenever they try to use FNA also. Teehee. Anyway, we end up with this sparse grid. It's got spaces in it. This is bad. If GPU drawing actually worked this way, anytime you rotated an image or scaled it up, you would have random holes in it. So instead what the GPU does is it looks at each actual position of pixels in the scaled up image and maps that back to the original PNG.
And this is just what your computer does. It's not your code, right?
Yeah, this is how GPUs work. So that means that this pixel maps to here, and then it clamps its value, or it rounds its value down, floors the value to figure out which pixel to use. Then this guy is here, and he also floors his values and finds the exact same pixel. And this guy is here, and he finds the same pixel. And this guy is here, and he finds the same pixel. And this guy is here, and he finds the next pixel. And what's great about doing this in reverse is no matter what, every pixel on the screen has to map to a real pixel in the original PNG.
So there's no gaps.
There's no gaps. There's no way for there to be a gap because we already know which pixels are on screen. So I'm doing the same thing here. So now when I have a collision, first what I do is I figure out what rectangle perfectly surrounds our colliding area.
Use red or something.
Okay.
I think.
So now I have a rectangle that tells me what the colliding area is, or like what the overlapping shape is. And now, when I look for an individual pixel in the rectangle, this is screen scale, so there's no way for me to miss a visual overlap, like something that looks like it should collide but isn't. And it must map to a pixel on the original image. So now I'm doing what the GPU does. I'm looking at this pixel in screen space and inverting the transformation back to the original PNG space. And I'm going to say this pixel is like here-ish. So if I do that for this pixel, for example, I'm going to find him like down here in this corner for the one sprite. Then the other sprite looks like this. And that same pixel was like, so we look at this. That same pixel is like maybe here-ish. So these 2 pixels in red that I have here, these 2 pixels that I have in red are in the same spot in screen space. So if both of those pixels are opaque, then there's a pixel perfect collision.
Okay.
And it's impossible to miss. It's impossible to find a situation where this pixel doesn't map to a real pixel in the original PNG. Whereas using
You
this
essentially
method-
emulated. Then there is, yeah. You essentially emulated how GPUs work and put it into your code.
Yeah, because it's like, if I can just check where the pixels are on the screen, then I can just see if they're overlapping at that point. And that's what I'm doing. I'm simulating what the GPU is about to do with it. So hopefully that makes sense.
Somewhat. I mean, yeah.
I mean, it's the same as what I explained earlier, but that's okay.
Yeah, it is. You know, I mean, yeah.
I'll put out a video on this at some point too. Anyway, transform not dirty is equivalent to just a regular transform now. Equals sys numerics vec2 dot transform. Paste that in there. We're going to use our transformation and then a semicolon. And then once more, bounding rectangle 4 corners number 3 is equal to system numerics vector2 transform. It's a lot of repetition. And then the new guy.
Back to cleaning up the code, eh?
Back to cleaning up the code. It never ends.
Never ends.
Okay, so that's collision matrix all cleaned up. Okay, so now I've got a lot of stuff. Yeah, that's crazy.
Oh, it's so mad at you. It's so mad at you.
I won't say it's happy. Yeah, because every single time I did a matrix multiplication, I was using this function that doesn't... Oh, it does exist. Oh, right, but this is now a system numerics vector 2. That's why.
Holy cow, dude.
So now we play this game.
The amount of red is crazy.
All right, editor, speed this part up. I don't think any of the chatters want to watch this.
I mean, it's getting to... I mean, it is past the
Like Squeaky
stream
said,
end
stop
time anyway.
abusing
But...
it. Is it? No, stream at 9 o'clock.
Oh, okay. Stop abusing it. How are you abusing it?
We were making fun of it and telling it it's bad and we hate it.
Oh, well, see, we do that to each other, so it's okay. We do
We
that to
deserved
people.
Cancelled instantly. Anyway, I'm gonna delete all
Jojo
of these
says-
comments. Oh,
Oh, Wasabi says they do want to watch the funny coding, so...
the funny coding. Yeah, the funny coding is I go in and fix all these terrible errors. Fills my brain with knowledge. Yeah, fills my brain with something.
Nobody...
I think it fills my brain with GERD.
I think my brain's been leaving my head for the for the last hour or so. I'm tired. Nothing to do with the stream. It's just I've had a long week.
No,
It's like
'cause
that
you hate
meme, like-
me.
It's like, oh boy, what a week. It's only Wednesday, Captain.
Editor has ADHD. Speed it up just for you. This game good. Okay. Oh no. Oh no. Oh no.
You deleted something that you shouldn't have, eh?
I did not. No, that's not the issue.
Oh.
Um,
Oh.
The issue is that System Numerics Vector 2, the reason I changed everything to System Numerics Vector 2 is because I didn't want to be instantiating new Vector 2s constantly, but it's not really going to be exposed to the end user, so I don't need to do it much. Unfortunately, this position of the actual object is exposed to the end user, and that gets its value directly from here.
Wait, run that by me again?
No.
Okay.
Sorry. So yeah, this collision matrix position, we changed it to a system numerics position so that we didn't have to keep creating new system numerics vector 2s in order to define the position whenever we update it. Right? Or whenever we use it for something else. Because, like, it gets used here, for example. Previously, in order to turn this from an XNA vector 2 to a C# vector 2, we had to create a new C# vector 2 and then set its x equal to position.x and its y equal to position.y. Right?
Okay.
When Squeegee says, "Don't worry, Japes," I also have no idea what he said. Very cool. Very epic.
Oh gosh. Oh, the chat's moving fast. I wasn't even reading it.
Oh yeah, there's just a couple people.
Yeah.
I thought you were going to quote the long day factory meme, Japes. Lag equals no, controls equals WASD, works equals true, graphics equals good. Oh, I actually missed a bunch of these. If game good, give $10,000. $10,000 collisions. Okay. I'm caught up on chat.
Me showing up to the Necrocen stream. Oh boy, I hope we don't have the Necrocen coding factory. Oh boy, I hope we don't have a Necrocen coding thing. That was a horrible attempt at trying to recreate the Long Day Factory meme.
I know what meme you're talking about, but I feel like I just got joke rage baited.
Sorry.
It's like knock knock.
It's like,
Japes,
what?
knock knock.
Oh.
Knock
Who's
knock.
there?
Orange.
Oh, Orange who?
Orange when you crying in the yeah.
No, I've been destroyed. I will never recover from this joke.
Hold on, sorry, I messed up the joke. Knock knock.
Oh, okay. Who's there?
Orange.
Oh, Orange who?
Orange when I'm crying and you Wait, sorry, I messed it up. Let me start over.
No, I've been
Knock, knock.
obliterated by a
Who's
joke.
there?
Oh, oh, who's there?
That's the joke rage bait. Okay, yeah. So problem is, all right. Let me explain this like I'm a 5-year-old.
Okay.
Oh my gosh. Do you see this? Do you see this right here? New vector 2. See that? You see it? You seeing this?
Yes.
If you see that, it's bad. It means my code runs slowly. Goodbye. Okay. If position is a FNA vector 2 and FNA vector 2, then in order to make this work, I have to turn it into a C# vector 2. So I have to do new system.numerics.vector2 position.x position.y. And now it works. But remember what I said about this, right?
No.
I said it's bad. You can't have this. No new vector 2s. Only old vector 2s. No new vector 2s. You understand me? This is your first warning. Do you understand me? Great.
In more serious stuff, Bunny Squeegee says that they can't post images to the Discord.
Images to the Discord. Oh, is that something I have to like explicitly allow now?
Possibly.
I have no idea what he said either. Editor, add bird on the screen. Can't send images. Your server. I want to send long day factory meme. Make the joke make sense. Fix this editor. Fix this. Gasp, not the vector. Guys, it's over. The new vector 2 code ruined the SDMP. I'm going to horribly splice the joke to make less sense. Understood, sir. Sleep deprived multiplayer Minecraft server with JSchlatt and Bird. Let me fix the stream. I'm gonna save the stream. If I mess it up.
I feel like my brain is just slowly spiraling. And I will justify it. Like, my jokes, if I find them funny, I find them funny.
It's him.
It's
He's
him.
back.
Oh yeah, Bird. Wait. There we go. Bird.
Oh my goodness. I hope one day Bird stumbles on my stream for absolutely no reason and is like, why am I here? Maybe a dream come true.
That would be amazing.
Can you explain the Vector 2 stuff with caveman speak? Oh boy. Did it, guys? We saved TF2. Mushbrain. Okay. If you see new Vector 2, that's bad. Old Vector 2, good. New Vector 2, bad. Okay?
That's not even a good explanation, though.
No. I'm setting up the explanation because if we have a new Vector 2, it's slow. It takes a long time for the code to make a new Vector 2. So if you see new Vector 2, it means I'm making a new Vector 2 and it's bad.
I see.
Are we on the same page?
Yes.
Okay,
yes.
Cool. Hold that thought. Grab it out of the air, eat it, whatever you got to do to hold that thought. He's too smart for caveman speak. I'm actually not smart enough to turn it into caveman speak. That's the real problem. So here we go. So now, so meow. So what I did
Meow.
to avoid having new Vector 2s, because every time I need to turn a C# Vector 2 into an XNA Vector 2, I have to make a new Vector 2 of the correct version. So in order to avoid doing that, I'm going to make them all the same Vector 2. I'm going to make them all C# Vector 2s.
The system numerics Vector 2, yes.
Yeah. No, not if Vector 2 world explode. If new Vector 2 world equals explode. We like our Vector 2s in general.
They do
Okay.
a lot.
They do almost two things. Just about. So this is fantastic, right? This is great. This is good. Because I've turned everything into the same Vector 2. The problem is, the rest of FNA wants it to be an XNA Vector 2. But I turned everything into C# Vector 2s. So I don't want to expose to the end user that I've turned them into C# Vector 2s. I want the end user to be able to blissfully keep using XNA Vector 2s, like the other kind. So when I come here and I have a position, he's a regular Vector 2, but oh my god! Oh no! Oh no! Oh boy! Oh no! I can't do it! I can't do it because this is a C# Vector 2, and I'm trying to read it into an XNA Vector 2. Oh no! Oh boy! Oh no! Oh no! That's bad. Have I considered Vector 3? This is gonna blow your mind. That's a Vector 3. But the game's in 2D, so it's going to be a Vector 2. Nice try, though. You're clever with it.
No, we haven't implemented 3D yet.
3D. More like 2D. It's going to be 2D. Anyway, this is
That's
a thought
what
I had.
said.
This is a thought when I think, this is the thought I had. Okay. Instead of get and is this, and this is what we get. Instead, what I'm going to do is
Yeah, we're waiting.
Instead, what I'm going to do is I'm going to set collision matrix Shoot. Okay. Instead, what I'm going to do... this is what I'm going to do instead. So instead, what I'm going to do...
Shot every single time he says instead.
Where is it? Where are my variables? Where are they? Okay. Private fields. So check this out. Private. Vector 2. Position. He's going to handle position, okay? Great. Fantastic. Cool, even. And I'm even gonna... I actually won't. I'm just gonna say... I don't know if this is required. If it's required, I'll fix it later. Anyway, now I have a position. Okay. So this is going to be... Our little position is going to equal... him. Okay? But that's not legal for the exact same reason. But I can say that the x value of position is equal to his x value. Now I'm not creating a new vector 2. I'm just setting the singular floating value. And I'm going to do that again.
Why is get mad?
Gets mad because I need to return something. And then I'm going to return that position. Okay? And then when we set things... I can do collision matrix dot position x is equal to value dot x, and I can... No, please let me do that. No, come on, please let me do that. Okay. Wait, I think I can do something really funky. I can do this with x equals value and y equals value dot y. Oh my god. Wow, that was literally the only syntax that would have been able to handle that, and I didn't even know about it a couple of months ago. Thank you, Tuesday. Okay, let me catch up on chat. New vector 2 equal bad. Necrosen said so. If vector 2 world equals explode. Have you considered vector 3?
Oh, you already read that.
Wait till he hears about Minecraft 2. Will this make our stinky little character not phase through the walls anymore? No, but it will let you detect if your stinky little character is phasing through the wall. It's up to you to make him not phase. Like you specifically,
see, that's a good...
Jojo. I'm handing the code off to you.
Oh no. That's why would you ever put such a burden on someone?
Funny.
This is years in the making.
Okay, all he has to do is fix the one thing, which is all of collision.
Yeah, well, I would not want to be laden with this burden.
Sorry, someone else's ADHD kicked in.
That's okay. We're all on the spectrum, and we all.
The visible light spectrum.
You're so right, brother.
No, I saw a great skit where this guy was like, "Hey man, isn't your kid gonna join us?" And he responds, "No, he's not on the spectrum." He's like, Why would you ask that?" And the joke is that the kid wasn't on the visible light spectrum. He's like a higher dimensional being.
Clever, I'll give it that. There's also way darker ways to take that joke, but we won't get into them.
I don't think you can take it darker if it's not on the visible light spectrum.
Oh my gosh, I walked into that one.
Don't you mean you jumped to a higher electron state into that one?
Nerd.
Hey, somebody get this guy a
textbook. I do appreciate that one, but...
Okay, so I'm going to do the exact same thing with image scale. I'm going to have to do the exact same thing with a handful of things. Wow, this is a nightmare.
Yeah.
Wake me up. Wake me up inside. I can't wake up. Wake me up inside. Image.
You know ProZD?
No. Yeah, I do.
You remember his cover of like Goofy singing "Wake Me Up"?
Oh, that was him.
Yeah, that was him.
Didn't he have a big voice acting role coming up? I saw that he made like a little post about it and said what it was, and I forgot what it was, and I can't find it now. I also haven't looked.
He definitely had a couple of minor voice acting roles in the past.
I thought he had like a major voice acting role though, coming up on.
I don't know.
Coming on up on.
That sounds like old news that didn't really happen. Because I kind of remember that, but I remember it was like almost years ago. But maybe I'm wrong. I don't know.
Oh, I forgot how. But now I remember.
He remembered.
Ah, if I do it that way, it fixes itself. Okay. Where is position? Okay, this is how I do it. Right. So hear me out. Image scale is equal to u dot x dot x and then dot y, and this is the part that gets everybody, dot y, and we're going to return image scale. Okay, fantastic. And now collision matrix dot scale is going to be equal to itself with, I have a feeling this is going to just make a new it and isn't actually better, but no, because this, at worst this would make a new vector 2, which is what basically just wouldn't save me anything, but I'm hoping it does something better than that.
Well, we can't even test it at this point.
Well, I'm actually asking what it's doing internally. The best we could do is either research it and see if that's what it does, or benchmark it and see if it's faster. But I'm not going to do either, because that's just how I roll.
Yeah, and we can't test it.
Can't
because
test
the rest of the code is borked at the moment.
No talk me. Yeah, that's what I'm gonna go with.
I'm just pointing out the truth, man.
Just because it's true doesn't mean you have to say it. Actually laughing at my pain. Okay, this collides with circle method. Check this out. Banished. This one, also banished. Oh, we're gonna collide with a rectangle? Oh, you're gonna collide with a rectangle? You're gonna cry? Why do I have 3 of these? Oh my, 4? Banished. No, actually the 4, like, the reason I have 4 though.
Chat, don't worry, he has a Git repository for all this.
Oh yeah, that was a lie. But anyway, I'm just gonna...
Oh, you're just shooting off the hip then, I guess, huh?
Shooting off the hip. I'm going to comment that out because I'm probably gonna want to know what the parameters were later. I'm gonna be like, man, why did I have 4 of these? Yeah, I don't want to do that. Ooh, I do want to do that though. I'm gonna get rid of you. Nobody liked you anyway. That was my
by the way,
nickname in high
Necrosin,
school. Yeah.
You're doing a good job.
Oh, thank you.
I was told to say that under gunpoint.
Oh boy. Oh my goodness. I need to pay attention to chat. That joke was peak, editor. Make that joke the highlight of the stream. See, Japes, they like your jokes. Japes, tell Necrosin he's doing a good job. Guys, it's over. He banished the code. It's broken now. Broken heart. No more rectangle collisions. Go nuts. We don't collide with rectangles anymore, guys. This is the most important glitch in the history of this engine. Oh my gosh. Axis-aligned bounding box collides with axis-aligned rectangle? Do I hear a
Don't
banished?
tell me you just had an epiphany. Does that mean a banished?
Oh, I was being funny. Yeah, it's getting banished.
Okay, good. Okay. I was like, don't tell me you had an epiphany now.
Guys, it's time to revert the code. 2 hour stream wasted. Then again, last month of my life wasted because I found a better pixel perfect collision algorithm and I'm deleting all this.
It's not wasted. You were working the entire time. And sometimes these things take time, you know?
You know, takes time when I finish the engine and realize that there was a faster method.
Exactly.
Um, more collisions, rectangle, rectangle. I think.
Maybe we can finally BLJ, is what JoJo said.
What is that?
He still doesn't know.
Oh no, was this a joke I asked about last stream and
It was like 2 or 3 months ago.
oh, the
It's
backwards long jump. Oh my gosh. I always forget that's the acronym for it.
Right.
Oh wait. We ran out of music. Stream over, guys. I was like, oh, be quiet.
Oh my
Nah,
gosh,
it's
there's
okay.
no voice in my head.
We have enough time to finish getting rid of the rest of these errors. It's fine.
Oh, really? You sure?
Who?
Are you sure that we have enough time to get rid of those errors? Do you see the amount of red?
Yeah, but it's mostly just deleting things. It's all banish. Banish, banish. Rotated bounding box clouds with axis aligned rectangle. Banished. Rotated bounding box clouds with axis aligned rectangle. Banished. Rotated axis aligned bounding box colliding? What are you?
Wait, Jojo, do you actually speedrun Super Mario 64? Because that's dope. I actually have Super Mario 64 on original hardware with a CRT.
Axis aligned bounding box collides with axis aligned rectangle. Pixel perfect.
I haven't been messing around with my N64 because I just got it like a few months ago. My dad found it in his basement, but he found Majora's Mask and Super Mario 64, and then I bought Ocarina of Time. And I still don't have the setup. I want to get like another table to put my CRT on to run the N64. But yeah, that's all I got.
That's pretty cool. I'm gonna keep this. Rotated axis aligned bounding box colliding. And then
Jojo says if you have original hardware, then honestly that's pretty peak. You should definitely consider getting into it. It's been fun. I agree. I think like the only two games I've ever tried to seriously speedrun were Breath of the Wild and Katana Zero. And they were fun. But I don't feel like I had the time to speedrun. To pursue speedrunning nowadays. Also, Neckerson, how's that code deletion going?
I think I'm like at the halfway mark. I know it doesn't look like I'm halfway down, but as I delete gigantic methods, the stuff above where the scroll wheel is gets smaller.
Right. Yeah. Because like the more methods you get rid of on top, the better it is.
Exactly. Trying to figure out. This guy. Okay, change collider. So here's another example where instead of this, am I allowed to do .x and .x? Or is it going to get mad at me because I'm bad at coding? It is going to get mad at me because I'm bad at coding. Okay, no, that's cool. That's honestly fine. I literally don't mind. I'll just cry. Yeah, just gonna grab you. And we're going to do another width. It's the same thing as before. Offset dot smex. Offset dot smy. Closing curly bracket. Cool. Didn't like that. Oh, right. X is equal to, and Y is equal to. And then same thing here. Oh boy. With X is equal to that thing dot X. And of course, the classic Y is also equal to that thing dot Y. Closing curly brace. I have too many equal signs. A classic mistake. Width and height. Classic.
You should check chat.
I will not. Alright, fine. If I had original hardware, then honestly, that's pretty peak. Should definitely consider getting into it. It's been fun. Bomb clip has been kicking my butt.
I was talking to JoJo about that stuff.
Yeah, I gotcha.
It's good.
Japes, tell Necro he should get a nice glass of water before bed. Tell him to get his full 8 hours. If he doesn't, he'll ruin the SDMP again. Nah, don't worry. This is all carefully calculated. I'm like halfway done.
Halfway done, he says.
Guys, I'm halfway done. I swear. You know, statistically, most kings kill their archmages mere moments before they finally find the elixir of life for real this time, guys. I promise.
Oh, that's what I tell my gambling buddies. Never mind. It was a joke.
It was a joke, guys. Do gamble. Gamble. I'm telling you to gamble. It's not a joke. I'm telling you to gamble.
100% of gamblers leave before their big win.
System dot numerics dot vector 2 dot 0 comma space. All right, guys, I'm gonna do it. I'm doing it. I'm gonna do it. I'm gonna do it.
Can do what?
New vector 2.
No, but that's bad. Streamer said it was bad.
Yeah, but this is on object instantiation. I can't really get out
Oh,
of
because so it was just it's a small little thing. Yeah, like in this circumstance, it's fine.
I could just die. Would that be better? I'm kidding.
Ooh.
What is this? Get collisions parallel. I don't remember what that means. Oh, I'm sorry. This is a parallelization. Yeah, I'm actually an addict. New System Numerics Vector 2.
We could all tell.
I don't think I can avoid it. It's really sad, but I don't think I can avoid it.
An addict to fixing your code.
I mean, again, this is just... So this is if I want a specialized matrix for the collision. I have to do this. So if I want to, like, have my player looking 3 pixels in front of himself to see if he's going to hit a wall, that's what this is for. So it's like, it's a very specific type of collision. This wouldn't happen very often. I swear.
Well, if we're gonna commit to a 3-hour stream, then I gotta go to the bathroom.
Oh, we're definitely not committed to a 3-hour stream. I'm actually at the halfway mark on the scroll wheel, which means I've done most of it. But you are more than welcome to go to the bathroom. You will be done with that before I'm done with this.
And we'll be done at 10.
I think you need to get fought is what happens.
Oh, I mean, we always fight. Not always.
No, but
But we
like,
fight.
I'm gonna fisticuffs you.
Ooh.
Yeah.
Let's go! Anyway, I'll be back.
Okay. Offset dot y. I forgot the comma. Great. It's fantastic. Alright, I see chat's been blowing up. Tell me guys if you're... do I hear 3-hour stream? Oh, he's excited. 90% of gamblers quit before they hit it big. No. Sending my love to the homies. Positivity stream. Remember, kids, be positive. I hope nobody gets that reference. I'm gonna get canceled. Okay. Moving right on along. It's a lot of hearts. I love you too, Jojo. You are... Okay. New system Eric's M position dot Y. New system M scale.x, M scale.y, closing parenthesis, new M offset.x, M offset.y. Okay. Great. Okay. Oh my gosh. New M position.x, M position.y, new M scale.x, M scale.y, new M offset.x, M offset.y. Okay. Oh, I forgot to say no. No. My finger hurts from tapping the hearts. You can stop tapping the hearts. I love you, Jojo. All of your love reaches me. I promise. Oh boy, not the separating axis freaking theorem. Let's go into you. You're going to be system numeric vector 2s from now on. And you're going to be system numeric vector 2s from now on. Hello back, I'm Necrosen.
Wow,
And today,
nice to meet you.
We're going to be building the fastest autocrafter.
Oh, that was an old video.
It's still my most popular video.
Really, actually?
Yeah. Okay. Oh, boy. Oh, boy, I say. When in fact it was a girl.
Oh, no. Cancelled.
Systematics vector 2. Systematics vector 2. Systematics vector 2. Oh, shoot. It's driving me insane. Systematics vector 2. Systematics vector 2. Vector 2. What are you? Systematics vector 2. Systematics vector 2. Okay. Systematics vector 2. Okay. Oh god.
He's descending. He's descending into the weeds. This is getting a little uncomfy.
What am I doing? That was all incorrect. Get interval. Bless you. My goodness.
Oh, I was laughing at you.
This is a vector 2 though. What are they mad about? What are you guys talking about? Oh. System error 82. Okay. System error 82. Okay. Oh my god. System error 82.
What is going on?
I sneezed. Sorry.
It sounded like something for sure.
Actually, extremely lightheaded. Way mad. Oh. This actually requires input. What? Oh, that's how it works? Gotcha. Okay, so apparently in FNA, XNA, this is an in-place function, but in C# version, it is not. Very cool.
What does that mean?
Don't worry about it. No, I'm kidding.
Okay.
So if I have a value and I run a function on the value, it will change the original value that called the function. That's in place. The other version of that is I call the function with the value as an argument, and it returns the new value to which I have to set something equal to it.
Okay. Sure.
I'm sorry. I'm trying to not make
No,
this
I mean,
a 10-hour stream.
Yeah.
I've genuinely apologized. Anyway, overlap
Nah, for what
vertices.
We're having a good time.
System error 32.
System
System error
System
32.
error.
System error 32. System error 32. Do you have a moment to talk about our Lord and Savior?
System new.
What? What are you mad about? Oh, right. Because this doesn't use system error. Starting to think this wasn't worth it.
Uh-oh.
That's okay. Because I'm starting to expose some things. I'm starting to expose examples of system errors vector 2 to the end user. But honestly, if the end user is using complex functions like these, they should probably be using system numerics. It's kind of the reason I'm using.
You know,
system
it's
numerics.
fine. Whatever bugs come out of this little...
Well, no, there's no bugs.
Whatever bugs come out of this,
bugs. There won't be
there
bugs.
will be
There won't
bugs.
be bugs. No.
You're gonna wake up tomorrow morning and spend the next week being like, oh my gosh, I did a thing here, here, and here that I did not agree with.
I'm gonna wake up tomorrow
And
morning
that's
and go to work.
okay.
Like millions
Yeah.
of Americans.
Like me, too.
Not like you, though. Different from you.
Oh, I'm special? I get to go to work and I'm like, I'm not like other Americans.
Where is my new problem? Oh, yeah, you. Wow. This is a lot of system numeric stuff vector too.
Theoretically, this is all making it faster, right?
Yeah.
So theoretically, the tower should be able to handle more collisions. Yes.
Whatever you say.
I'm just asking.
No, I'm being funny. That was the... Right, yeah, it's totally gonna be faster. Okay, and the rest of this I'm gonna comment out. IDK if this saves me anything, but it makes me feel good.
I remember you writing that. I remember you writing that.
All that. Get rid of all that. Oh wait. just gonna... I don't need this anymore. It's wild. It's a wild thing to say. Okay. I'm gonna put a closing comment there. And all the way up here, I'm gonna put an... Oh, man. This needs to be commented. I'm gonna opening comment here. That should comment out everything. Look at that!
Damn.
That knocked out the rest of our red.
No, it didn't.
It did on this function. Alright, perform transform doesn't exist anymore. This is for dull collision matrix. Honestly, I don't think dull collision matrix needs to exist anymore.
I'll believe you.
Oh, gosh. Right, because I'm doing things. Oh, okay. This is the demo stuff now.
Oh boy.
I've got half a mind to delete like all of these cases because they aren't working now. But I won't. I'm just gonna comment out what's currently red. And that won't hurt me later. It's okay. I'm not running a demo on this right now. And I already know my overlap methods work. So I don't need to benchmark them. Well, I do need to benchmark them, but I don't need to like test them the way I was testing them earlier. So we're just gonna comment all of this nonsense out so that I can actually run something. Okay, that's commented out. And now there's still one reference to dull collision matrices, but I'm gonna get rid of this entire class now. Oh, goodbye.
Wow.
Alright, let's see which errors we get. Only 17 errors, that's not bad. I'm gonna comment all of it out. No, because I'm commenting all of it out though.
Oh, it's just so funny. There was that just reminded me of this is, can I tell a story?
Yeah. I'm sure
Okay.
I'm not entertaining the guests.
So there was for my engineering like final project, which is like the equivalent of a thesis, you know.
Yeah.
We had to make a self-leveling cart, like a push cart system, like you push books on and like the top of it would like self-level down like any slope you do.
Yeah.
And like this was literally right after I got married, and I had one more semester in college, and my college was an hour away, and I had to drive there 3 times a week. And the first time we got any sort of semblance of code working, the like oscillation on it, like it was horrible, right? Like the cart just moved like back and forth, and I was the one pushing it, and I just started like cursing the entire way. And I'm like pushing it down, and all the rest of my teammates just start doubling over laughing. And after it, one of the guys was like, well, there was only 17 and a half curse words. That's pretty good for a first run.
Oh my gosh.
Because it was like 11:30 at night. I still had to drive an hour to get home.
Oh my gosh.
We did end up with the best project in the class, though. I will say that.
That is pretty neat. It was all worth it in the end.
It was all worth it in the end.
It wasn't worth it. This is immediately stopped being worth it, whatever it was I was doing here. Goodbye. Get commented out. Idiot. Oh, you don't want to get commented out? Get commented out anyway. Crazy. Oh, what's this? Not commented out code?
Oh?
Wrong. Goodbye. Oh, what's up here? Oh, you think you're people. Get gone.
Whoa. Whoa.
What? It's not a weird phrase.
Hey, I like edgy jokes.
I think you think that means something else, or is like from something else, and it's not.
Take it out of context, man, and it sounds
No, there's
pretty
no
bad.
context. That's a normal phrase.
Really?
Yeah.
Oh. Well, I was educated today. The coolest thing too about that self-leveling cart is that after the professors like um looked at it and like evaluated all of our projects, we all of us students just started messing around with it, and it was the coolest feeling. What are you bringing up?
He thinks he's people.
Ah, from Archer. Okay.
Not necessarily.
I never watched Archer.
I think it's just like
Oh,
a
and
dog. I think it's like a dog thing. Maybe it is from Archer, but no. Pretty sure I heard that way before Archer. Anyway, that's the
okay.
meme. I'm gonna hit run. Go on.
Yeah, after the professors like evaluated our projects and stuff, we just started messing around with like, oh, let's like push people in carts and stuff, you know, as college kids do. And I got to ride it one time, just once. And how do I explain this? So they ran down a hallway and then just abruptly stopped. And because of the technology that we used for like the self-leveling system, it was a I don't remember what it was, but like it was an accelerometer that we used to make sure that the cart stayed level. So because they abruptly stopped, the bed of the cart like moved, like tilted forward and caught me. So you abruptly stopped, but you didn't feel any G-forces. It was honestly pretty cool.
Alright. Oh, this is interesting. On my other monitor, it started to run smoothly.
Really?
It did. It slowed back down again. What? It was like starting to speed up and then it slowed back down again.
On your other monitor.
On my other monitor.
And not this one.
Yeah. Currently watching on the other monitor, see if something different happens. Oh. Well, 70 is still too much. But I haven't made it more efficient yet.
You just cleaned
okay.
up the code.
Yeah. Something. I honestly need to look through like every single one of these members and make sure they're not like generating a new vector 2 or actually that's it. I need to make sure none of these guys are generating new vector 2s because that's what's going to save me lots of calls. But okay, so one thing we can do here before I totally log off, we actually do have a way to benchmark things. So what I'm going to do is you're going to run this for a little while. Look at that.
Ooh, and see if it improves.
Very exciting. No, what we can do is go to the diagnostic tool and go to apparently it wasn't recording. Okay. Is it now recording? And this is going to tell us like on a per function basis. Oh yeah, it's running smoothly right now. But if I like move it to the screen, it slows way down and won't go back up. And it won't go back up again if I move it to this screen either. What the heck?
Oh.
Big. Anyway. Yeah, I'm gonna stop it here. Go back to our diagnostic. Open details.
Oh.
Loading. Coolio. Game.run took up 95% of our system calls, which kind of makes sense to me. And I don't remember exactly how to do this, but we want to look at current view. Yeah. Let's go to flame graph. No, not flame. Oh, flame graph is fun, but I want to go to call tree. Okay, yeah, check these guys out. So it's like out of that entire run, 17%, 24% of it came from whatever this is collidable.
It's old, isn't it? That's really old.
What?
Is collidable.
No, this is just checking if the object we're colliding with has something that disables collision for it. Like, it doesn't have a sprite attached to it. Collisions have been turned off for that object. What are the options? Yeah, it's already been deleted, or it doesn't have a... or collisions have been turned off. Those are the two options.
Guess I'm wrong.
So this is still required. We're still using this. But that's chill. 1% of our time came from separating axis theorem. 0.25% came from the rectangle. So you might so this is where you have to be careful, right? If 1% of our time came from separating axis, and 0.25% came from Sutherland-Hodgman, then my prior theory that this was going to be faster than this was actually wrong, because this took a higher percentage of our runtime, right? No, that's not why. What actually happened...
Teach, you lied to me again.
Exactly. What actually happened was we ran this a lot and immediately caught a lot of non-collisions. So it didn't even get to this code, and therefore it didn't take up a lot of our runtime.
What does that mean exactly?
I'm saying this actually caught non-collisions and broke us out before we ran this algorithm.
Okay.
So this decided there was no chance of a collision and said, don't run this because there's already no chance of a collision.
Okay. That seems good, right?
Yeah. So even though this took 1%, this ran possibly 1,000 more times than this did. You know? Because it has to get past this to even run this in the first place.
Wait, so what's your point?
My point is that this is still faster.
Okay.
We do this check first, and if there's no chance of a collision, we break out. We return false.
Yes.
We only do this if there is a chance for a collision. So this gets run significantly less. And that's why it has 0.25%. That's why it seems like it took less of our CPU than this one did. But in reality, it just wasn't run that often.
I see.
On the other hand, check this guy out. This took 18% of our runtime. That is significant.
That's a lot.
So what is this doing? Vector 2 inverse transform. I thought... And there might not even be anything I can do about this. So I go to... How do I open this? Shoot. Here it is. Vector 2 inverse transform. If I double click on that, we can see that calculate bounds and matrices took 17% of our time. And if I look at calculate bounds and matrices, you can see that... What? What is this?
The bracket takes 17% of your time.
Apparently. Anyway, what this tells me is we just ran this a lot and said that, yeah, this prevented us from recalculating the matrix many times.
Right.
which
So
is good.
these two functions are like stuff to look into.
I mean, maybe. Um, we spent a lot of time checking if we needed to recalculate stuff, but we would have spent way more time actually recalculating stuff.
Sure, yeah.
So,
But if we want to make it faster, these may be the things to look at, right?
maybe, but this is also already so simple. Literally, all this does is check a single boolean to see if we should continue to do stuff. Like, there's not too much you can do to make it faster, other than like finding somewhere else to factor this out. But this is like kind of, there's no obvious fix for this. Basically, this is not an easy like, oh, I shouldn't be doing this.
Right.
And then it's kind of like peanuts after that. So 88%. It's like kind of running as fast as it could, to be honest. It's getting mostly hung up on calls that prevent us from doing too much work, which is what we want.
Okay.
So it's like I want to go back to like this for a second. So our separating axis theorem. So let's go into this guy. Let's see where we're taking time, right? I mean, these are all super fast. This is 0.37% of our time. I mean, this is just making a new span, rather. We can see like what overlap is doing. So overlap on axis. We can see what get interval is doing. Where's get interval? Oh. Get interval. You gotta do a dot product, and then it just returns. Like we're forced to do a dot product, and then it just returns. So, I mean, every individual thing is super fast. It's a per pixel collision. Like, you get what you pay for.
Yeah, you're essentially saying that it's pretty hard to actually make this faster at the moment.
Yeah, and this is why nobody likes per pixel collision, right? If this was just rectangular collision, we could have way more things going on.
Right, but that doesn't feel good as a gamer.
No, that's not true, actually. It's generally frowned upon to use pixel perfect collision ever as a game developer.
Really?
Yeah. It doesn't feel that good.
So we're gonna implement it.
Yeah. I like it. Yeah, well, especially with GJK, like, an argument for pixel perfect collision is like, okay, but I want my collider to be a triangle, so I made a triangular collider. So you go, okay, fine. But since we also implemented GJK already, you can make an actual triangle. So...
Yeah.
Or like, okay, another example used for pixel perfect collision is for terrain. Like if you have a top-down game, or even a platformer. If you have a slope, it's really easy to have your character check for where the pixels are to decide if it should like move diagonally along the slope.
Yeah.
Because it'll like if it's up against a slope like this, like that, the player's up against the slope right here. If you just check for collision before it stops, it'll stop here. But if then you go, oh, I'm colliding, what if I move over 1 pixel and then try to go forward? And if that's allowed, then it's like, I must be up against a diagonal wall. Let's start sliding.
Right.
So, like, that's a legitimate use case for pixel perfect collisions. But I mean, the argument to be made is like, but you could also just have a diagonal line, like actually programmed as a diagonal line, and use like some physics-based math. But wrong. I'm not gonna do that.
Well, that's something for another time if you want to think about it, right?
Well, I'm saying like that's per implementation, basically.
Right. Oh yeah, I guess. Yeah.
That's whatever the developer of the game wants to do with it. I think Pixel Perfect Collision is extremely good for a general use engine. You should have it.
I think it's great to put it in the engine, yeah. And if the developer wants to implement it, then they can.
Yeah, even if it causes me 2 whole months of suffering. Yay.
It's fine though. You got friends to bring you through it.
That's right. I got you guys and strangers on the internet. I love the strangers on the internet. But yeah, at the risk of Japes making fun of me and telling me this was in fact a 3-hour stream, I'm gonna call it now. Thank you everybody for coming to the stream. I want to die a little bit, not a lot, but a little bit.
Oh gosh. Okay, I'm back. My internet just died for a bit. What'd you say?
I basically did a stream outro. Would you like to say goodbye to the fine people?
I would. I was lamenting the fact that like I wasn't. And yes, my internet is stupid sometimes. Goodbye, folks. I
Guys,
will.
I made a
We
tiny,
will see you next time.
I made a tiny bird in the bird eyeball.
The bird eyeball is the bird. It's birdception.
Him.
Him.
I'm gonna go to sleep. Yeah. Bye everybody.
Bird. See ya. Thank you everyone for joining. It was always fun. It was fun as always.
Yeah. Yes. All good. I'm gonna hit the end stream button now. You good, Japes? Any final words before you cease to exist?
No, I just had fun.
Oh, okay. Okay, goodbye. Bye, everybody. Goodbye. Bye, everybody. See you later. Goodbye. Bye. Goodbye, everybody.